Today we're going to start specific types of functions. So we're going to do linear functions first, and we're actually going to graph them first. So this is on page 40 of your notebook. 40 is 5.1, graphing linear functions. That's also the title for 41, but we won't get to that today. There's a lot involved with graphing any of these functions. We are going to recognize a lot of features, okay? We're going to do this for every single type of graph when we function when we graph them, okay? I do want you to go ahead and do something for me before I forget, and that's to turn back to your tab. We do not do this one. Go ahead and cross this one out. We did in years past, but we're not doing this one. So that shouldn't be there. And this will be on 40 and 41. Okay. All right. So I'm going to put my notebook to the side, but of course, if you don't have this, you're going to write in your notebook on 40. All right, so here's what I got going on. I've got linear functions, and I'm going to talk about these linear functions. I'm going to graph them. And do those kind of things. So let's talk about first, before we graph, let's talk about the key characteristics here. First of all is slope. Slope, you might also see it as rate of change. Slope can be represented in a couple of ways. Slope is normally denoted as m. This slope formula is y2 minus y1 over x2 minus x1, which is the same as the change in y over the change in x. This is supposed to be a box. I don't know what happened to it, so we're going to kind of get a straight edge and box this off. Okay. That's what slope is. X-intercept. An x-intercept is where the graph crosses the x-axis. Wherever the graph crosses the x-axis, the y is 0. We're going to talk about y-intercept. We'll come back to end behavior. The y-intercept is where the graph crosses the y-axis. Just like the x-axis, x is 0 in that situation. We'll come back to end behavior. Domain is the x values for the function. We've talked about that before. Range is the y values for the function. Okay, now we're going to talk about end behavior. End behavior is talking about what's going on from left and right, left to right. We will be talking about what is the graph doing on the left side, but you won't see it as left, you will see it as x approaches negative infinity. We will also talk about what's going on with the right side, but you won't see it as right, you'll see x approaches infinity. That literally says x approaches for both of these. That's what the x and the arrow mean. Okay? We'll talk about what's happening with each of those. And the answer will actually be what is y doing when x does those things. Okay? All right, for today's lesson, you're going to need a straight edge. Because this is linear functions, so they're going to be straight lines. We're going to highlight the slope today in green, the y-intercept, the x-intercept in orange, the y-intercept in pink. And we're going to do that every single time. Okay? Green, orange, pink. Okay, let's talk about number one. Number one, this is in something called slope-intercept form. That means that our slope and our y-intercept are given to us. Our slope is right here, 4 over 3. So slope is 4/3. The intercept at the end of this is the y-intercept. When we have the y-intercept, our x value is 0, our y value is 3. So we're going to graph this. Once we graph it, we will find the x-intercept, the end behavior, the domain, and the range. So let's put a point on 0, 3. Start at 0 and go up 1, 2, 3. Okay. Now, I need to, this is rise over run. I need to go up 4, 1, 2, 3, 4, and over 1, 2, 3. Since that's off the graph, I'm going to do the opposite. I'm going to go down 4, 1, 2, 3, 4, and left 3, 1, 2, 3. Take your straight edge and connect it. You only have to have 2 points to make a line. That's it, just 2 of them. Okay, let's talk about that. This slope is fine because I go up 1, 2, 3, 4, and over 1, 2, 3. We just wanted to check to make sure we did that right. 4, 3, from left to right. Okay, the y-intercept is where it crosses the y-axis. That's right there. The x-intercept is where it crosses the x-axis. We're going to have to kind of estimate it. We will learn how to solve for it later, but right now we're estimating. So it looks like that's between -2 and -3, which would be -2.5. We will learn how to solve for it later. Okay, in behavior. In behavior, I'm only going to write left once. Left means what happens when x approaches the negative values. When x, right here, when we are going towards the negative values on x, y is also going to the negatives. It's going down. That means my answer is y approaches negative infinity. In case you're confused, this is what is the answer. Okay, now let's talk about it on the right. As x approaches positive infinity. So when x is going towards the positive numbers, this line is going up, so y is approaching the positives as well. They will not always match. They did here. These are the answers. These pieces, okay? All right, domain. Domain means what x values are appropriate for this function. Well, right now, it looks like they're all appropriate. If this went on forever, then every single x value can be used. To say that, then we're going to say all real numbers. There is a shortcut for all real numbers, and that is R with 2 lines. This is what we will use from now on. Okay, range. This is going in both directions, above and below. So same thing, all real numbers. Again, there is a symbol for that. R, but with 2 lines. Not an I, 2 lines and an R. Okay? That is how you graph these and identify the characteristics. Okay? We are going to open this foldable and do some more of these. Alright, slope is 3. Slope, I need a fraction. If it does not have one, it is over 1. Y-intercept. I highlighted these backwards on the front. Of course I did. We're going to highlight the y-intercept in pink. even though I've changed it on the front on accident. The y-intercept is the value right here, 0, negative 5. I have to graph it to find everything else. So 0 and then down 5. The slope is up 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. Remember, I technically only have to have 2 points to make a line. I would connect them all the way through, though. I need it to cover the whole graph because I'm going to need that x-intercept. Alright, so the x-intercept is where it crosses the x-axis. It looks like it crosses the x-axis between 1 and 2. So let's say 1.5. Okay, in behavior, as x approaches the negative numbers, y does what? X is going here, so I'm looking at this left side of this graph. My screen froze, and I'm sorry, so let me unfreeze it. Okay, write that down. Pause it if you need to. Sorry that it froze like that. So when x is going towards the negatives, I'm just looking at this left side here. What's going on? Well, that's going down. That means it's going towards negative infinity. Okay, that's the left side. Let's look at the right side. When x goes to positives, positive infinity, so this is the right side, it's going up. So y is going towards the positives, which is infinity there. Okay, domain. All linear functions have a domain and range of all real numbers. The only time something doesn't have a domain and range in all real numbers is when they don't have arrows pointing in both directions, but lines do. Number 3. Slope is negative 1/4. It's got a fraction, so we're good. Y-intercept is 2, 0, 2. Let's put a point on 2, 0, 2. Go down 1 over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. Yes, I did something strange. You're going to see why. I went off the graph. Isn't that crazy? You're going to see why I went off the graph in a minute. Okay, here's why I went off the graph. I could not see the x-intercept, but I could find it. Here's how I can find it. This is down 1 over 4. Well, to find the x-intercept, I would have gone down 1 and over 1, 2, 3, 4. That's at 8. 8, 0. If you can't find it, continue your point until you do find it. So there it is right here at 8. All right, in behavior, as x goes towards the negatives, and then as x goes towards the positives, what does y do? That's what we're looking at. So the left side, this is going up, so this is infinity. See, they're not the same this time. This is going down, so this is negative infinity. Again, domain and range are all real numbers. Okay, I'm going to move this. I want you to do number 4, and then 5, and then 6, and then 7. I want you to pause it. I'm going to work them and just keep going, but you need to pause it. Do 4, start the video. Pause it. Do 5. Okay, you need to pause it between every single one. The slope for number 4 is 2. Remember, you need a fraction, so it's 2 over 1. The y-intercept is negative 4, and we write that as 0, negative 4. Zero, negative 4. Go up 2 over 1, up 2 over 1. I've got the x-intercept right there. Make Make sure you're putting arrows so you know it goes on forever. That is important. The x-intercept is right here. The x-intercept is 2, 0. In behavior, what's going on the left? When x goes towards the negatives, what does y do? When x goes towards the positives, what does y do? The left side over here, it's going negative, it's going down. And on this right side over here, it's going up. So infinity means up, because it's going towards the positive infinity numbers. It's a line, so domain and range are still all real numbers. I hope you don't miss that on a quiz. You will have a quiz. Okay, number 5. Slope is 9. That might be a problem. We might not have enough room on our graph. Remember, I need a fraction, so 9 over 1. Y-intercept is -4. Remember, we write it as 0, -4. Put a point on -4, go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. We're definitely going to have a problem with our x-intercept there. All right, now remember, we're still guessing the x-intercept. Tomorrow we're going to talk about how to actually find it. So this is a guess. This is not the actual one, I promise. I'm going to say that's close to a half. That's not the actual x-intercept. The actual x-intercept we will learn how to find tomorrow. To find the x-intercept, you actually set y equal to 0 and solve this equation. You get 4/9 there. But we'll talk about that later. Okay, in behavior, when x goes towards the negatives and when x goes towards the positives, what is happening to the y's? This one's going down on the left side, up on the right side. The domain is all real numbers. Number 6, slope. -3 over 2. Y-intercept is 1. 1 down 1, 2, 3 over 1, 2. X-intercept, again, we're guessing. We haven't learned how yet. It's somewhere in between here. It's not quite a half. It's a little over that. But we're going to put a half. And we're going to learn how to find the real number tomorrow. It's actually 2/3. All right, in behavior. Here, this one's going up, so the left is positive. This is going down, the right is negative. Domain and range, again, are all real numbers. That will not change this week because it's going both directions. When it's not going both directions, it will be something else. All right, last one. I hope you've paused this and have tried them on your own because it's not going to help you if you haven't. We're going to keep doing this tomorrow, but they'll be in different forms, okay? All right, so slope, -1/2. Y-intercept, 0, -2. Down 1 over 2, down 1 over 2, down 1 over 2. I don't have an x-intercept. I could go up and left till get there. There we go. It is there. This one, the x-intercept is perfectly at -4, 0. And in behavior, when x is going to the left, and when x is going to the right. When x is going to the left, y goes up, so it's positive. When x is going up or going towards the right, y is going down. Again, that didn't change today. All right, so remember, if you had your notebook, you were writing on page 40. I'm gluing this in on 40. Tomorrow we'll finish graphing linear functions. We'll have different forms. We'll have standard form and point slope form. So we'll work on that. I'm going to glue this in, and I will see you tomorrow.